Experimental probability. So first let's talk about what is probability. Probability is just a chance something is going to happen. That's it. What are the odds of this thing happening? That's probability. Now, probability goes from 0 to 1 because we say if it has a 0% chance of happening, then it's impossible. It's not going to happen. And if it's going to happen, if it's certain it's going to happen, it's 100%. And then we assign that probability as 1. So 0% chance of happening is 0, 100% chance of happening is 1. Everything else falls right in between. And if you're at 50%, like you're the same odds of not happening as happening, then it's 0.5. Now there's two types of probabilities we're going to talk about. Experimental probability, which is literally based on an experiment. So like you get your data from an experiment. And theoretical probability, which is based on mathematics, what should happen based on mathematics. Now in this lesson, we're going to focus specifically on experimental probability. So everything we're going to do next is all about experimental probability. So let's do some vocab for experimental probability. Number of trials. So remember, we're doing an experiment. Number of trials is literally just the number of times you do the experiment. Outcomes are what are the results. Frequency is how many times a certain thing happens. And relative frequency is where you divide your frequency over the number of trials. So you get a relative frequency. So for example, let's say we play this game where we throw a plastic cone in the air and it either falls on its base like this or it falls on its side. Well, if we run that experiment 279 times, that's my total. And it falls on its side 183 times, and on its base 96 times. So the total number of trials is 279. That's how many times we did it. The outcomes are side and base, right? Either fall on its side or on its base. The frequencies are given. If I wanted the relative frequency, I'm just going to divide these guys by the total number. So relative frequency for lining on its side is 183 over 279, which is about 66%. And the relative frequency of following its base is 96 over 279. And you can see there, that's also just the probability. Experimental probability is just the relative frequency, right? So if I ask, based on the experiment, what are the odds it's going to fall on its side? You would say about 66%. What's the odds it's falling on the base? About 34%. And you add those two up, you get 100%. Okay, so let's do another example. Bit 2 records the number of phone calls she receives over a period of consecutive days. How many days did the survey last? So keep in mind, let's look at this table. So this is the frequency. This is how many phone calls she could possibly get in a single day. This is the number of calls per day. So she got 0 calls, 1 call, 2 calls, 8 calls, whatever. So total number of days it lasts, it doesn't tell you right here. You got to add everything up. So we got to add up all the frequencies. This is what, 2, 7, 11, 8, 7, 4, 3, and it looks like 1. So we're going to have all those frequencies, and I get 43. So how many days does the survey last? That lasted 43 days. Estimate probably that tomorrow, but still receive no phone calls. So what they want an experimental probability that should receive no phone calls tomorrow. Well, no phone calls would be 2, and you put it over the total frequency, 43. So I get whatever that is. 2 divided by 43 is about 0.05. Now 0.05 is the probability. If I wanted a percentage, you just multiply by 100 and you get 100%, 5%. So 0.05 is the probability, totally fine. Or you could say 5%. Now again, it said estimated probability, so I'll stay with 0.05. 2, 5 or more phone calls. Now this is interesting. It's 5 or more. So she got 5 phone calls 4 times, but it says or more. So that means 5 phone calls, or 6, or 7, or 8 phone calls. Right, 5 or more, that's what that means. So how many times so we add up all those. 5 is 4. 5, we're going to add up how many times she got 5, 6, or 8 phone calls. You just add them all up. So 4 plus 3 plus 1 is 8. So that's how many days she got 5 or more phone calls. And then we're going to divide it by the total number of days the survey lasted, which was 43. And then we could divide those two to get the probability, which would be about 0.19 or 19% if you wanted to go that way. So that's how many days she got 5 or more phone calls. And then the last one here, less than 3 phone calls. So she wants to get less than 3. Right? Again, it's how many days does she get less than 3? So here's 3. I want less than that. So it's going to be these guys. So 11 plus 17 plus 7, which is 18, plus 2 is 20. So 20 days she got less than 3 phone calls. And then you want that over 43. And then we just divide that to get our probability. And we get about 0.47. So you had 40.47 probability or 47% probability of getting less than 3 phone calls. Okay, let's go on to the next one. Table below shows the number of short-term visitors coming to Australia in the period between April to June 2018 and the main reason for their visit. So it's just a bunch of data. Estimate probably that a person who visits in June is on holiday. Okay, so a person who visits in June is on holiday. So here's holiday, here's June. So we have that many people visited in June for holiday. And again, we're trying to find the probability. So I always think about it this way. It's 1 over total. So total is, what are we talking about? We're talking about people that visited in June. So my total is not going to be this or this. It's going to be the people in June that visited. So my total is 308, 300. And I want the number of people that went for holiday. So that's 156 or 500. Then we can divide those two to get our probability, which is approximately 0.508. So almost about a 51% chance that the person visiting in June because of holiday. B, estimate the probability that person who came to Australia in the periods of April through June arrived in May. So they're saying that people, of all the people that came, all these people here, what's the odds that they came in May? So same idea, 1 over total. My want is I want the people in May, so it's going to be 260,900. And then the total is going to be everybody that came through those 3 months. So I got to add up these totals here. So my total from April plus my total in May. And those do not cancel because this is being added, so you can't cancel like that. And then plus my total in June. So you add all those up and divide, and we would get this. Did off camera. So add all these, you get this. Divide those two, and here's the probability that if someone came to Australia in those 3 months, what's the probability they came in May? That probability. And last one. Lars arrived in Australia in April, May, or June to visit his brother. Estimate the probability that he arrived in April. So same idea, but now it's April. Now, actually, it's a little different. So April, May, or June to visit his brother. So I mean, he's visiting friends or relatives. So that's why he came. So actually my total is going to be that, because I have more information. So my total is going to be these 3. So these are the odds he came in April to visit his relative. So here's the total, all possibilities. And then we want to figure out the estimate the probability that he arrived in April for that. So April would be this one. So 77500. And if we set that in, we get about 0.408. So there we go, and that's the lesson.